assembly. And a single line runs up from this to feed the shower head. Pipes also come down from the faucet and run through the wall to feed the sink. The copper line that Dean roughed in will tie into the cold supply for the sink. As we fit all these pipes together, we've cleaned and fluxed each joint. And now we can sweat all these connections at once. This faucet assembly required some pretty complicated teeing and elbows to supply water all around. For the shower head, we end the run with a threaded eared L. The shower head will eventually screw into this.
Once the copper in the wall is sweated together, we can make up the lines that run into the ceiling and over to the point where we'll tie into the existing plumbing. All right, we've run all of our lines up to this point. Now we can tie into the feeder lines. And because it's a fairly compact area, I'll use a smaller pipe cutter to make the cut.
Say, Dean, you better wait a minute there.
But first we'll turn off the water. Just about forgot about that.
To turn off the water, I just close the valve that's located right underneath the water meter. Then we drain the pipes. And this is done by opening the faucet that's lowest in the system. And for us, that's right here. Water runs right through this hose and into this floor drain. But to completely drain the system, you should also open up the faucet that's highest up in the system. Go ahead, Dean, I'm ready for you. This eliminates any reverse pressure in the lines and allows them to fill with air. Okay, Dean, you're all set.
Okay, good. So, as I was saying, we've finally reached the point where we can cut into the existing water lines and hook up the lines for the new bathroom. As you can see, the plumbing contractor left a T in each line for just this purpose. So now all we have to do is cut off the caps and make the connections.
Once the plumbing rough-in is done, you want to secure the pipes in their holes to keep them from rattling around. Small bits of fiberglass insulation work just fine for this. Stuff it into the holes in the studs where the pipes run through, and tamp it between the copper lines and drain pipes.
Fire regulations also may require that any gaps in the top plates around the plumbing are sealed up. Fiberglass can do the trick here too.
To finish up, we'll install 2x10 blocking, which will be needed to hang the pedestal sink on.
And finally, we can fill the dirt back into the shower drain area.
There we go, easy. Well, we've done the rough plumbing for one bathroom, the smaller one, and that just involved pipes and fittings.
But when you have a bath with a tub in it, it's important to have that tub delivered before the rough-in begins. That's so it can be installed at this point. You have that open there?
Yeah. There are a couple of reasons for this. First, you may have to take out a couple of studs just to get it in place.
Okay, that's good. Second, we'll need to run our wall covering over this flange, so it makes sense to have the tub in now.
And third, you want to install the tub while the walls are still open so you can get to the back side and install the drain system.
Again, we're working in a recess in the flooring. In fact, we had to widen it a little with a sledgehammer. The first piece to go in is an assembly for the main drain and the overflow drain. A trap assembly connects to the existing drain pipe. And a short PVC extension runs between the drain assembly and the trap. For the supply system, it's really a matter of personal preference, but we usually locate the spout at 20 inches, the control at 30 inches, and the shower head at 80 inches above the floor. Otherwise, everything else in this bathroom is pretty much the same as we saw in the smaller bathroom. Now, plumbing is a fairly complicated subject. We've only shown you a few of the steps involved, so if you're not experienced with plumbing work, you might want to check out our basic plumbing videotape to get more comfortable with some of the procedures.
The last part of the rough-ins for the mechanical systems is the electrical work. Again, a lot of this was prepared for us when the house was first built. You can see that this electrical sub-panel has room for several new circuits. Any circuits we wire for the basement will get connected here. You don't absolutely have to have a sub-panel in your basement. It'll be easier to run cables from here, but you can run cables to the main panel, wherever that may be.
Our basement, like most others, is wired for only a couple of lights and outlets, so we'll be adding quite a few more circuits and also drawing a lot more power.
This house has 200 amp service, which will be plenty, but in older homes or in homes where a finished basement wasn't part of the original plan, there may not be enough power back at the main panel.
If you have any questions or doubts about the capacity or condition of the existing electrical service, contact a professional licensed electrician.
There are a lot of code requirements for wiring new construction, and if you think about them, they all make sense. Well, for instance, when you walk in a room, there should be a light switch right near the door. So, I'll install a switch box here. Boxes usually just get nailed in place on the side of a stud. You see how I've spaced the box so the front sticks out past the edge of the stud. This is so that when we put half-inch drywall on the walls, the box will be flush with the surface of the drywall.
Now the switch has to control something, right? Sometimes it can be wired to turn an outlet off and on, and then you plug the lamp into the outlet. But most of the time, it's best to control the overhead light by the switch. All right, this is the box for the overhead light. Now we have to think ahead a little bit, because sometimes we use 5/8 inch sheetrock on the ceiling. If that's the case, we'd want to hold the box down about another 1/8 of an inch. This way the box will be flush with the drywall once it's installed.
Of course, the two boxes need to be connected, so we'll need to drill some holes through the studs. A right-angled drill is best when you're making holes for electrical cables. The holes run through the studs at about knee height and as close to the center of each stud as possible. The cable will have to run up, too, so I drill a hole in the top plates here.
Okay, we're ready for some cable. This type of cable can be used in just about any basement remodeling project. It's called Romex, the brand name after the company that invented it. It has 2 or 3 conductors and a ground wire that's encased in plastic sheathing. This type of cable is good for do-it-yourself projects because you can just run it through the holes in the studs. When you have to run it along the side of a joist or stud, it needs to get stapled to the wood at least every 4 feet.
The ends of the cables get pulled into the boxes. Usually this means using a screwdriver to break out a small plastic tab called a knockout. Then the cable just gets pulled through the knockout into the box.
The cable I'm running will feed power to the switch, as well as to outlets in the walls around the room.
Which means, of course, more boxes, more drilling, and more cable.
As we saw when we were framing, the fact that the basement is already insulated can be a nuisance. To install the boxes and drill and run the cables, we have to peel back the polyethylene vapor barrier and pull out some of the insulation. Now, these boxes are for receptacles, which are required every 12 feet along the walls.
Where we're going to have a fixture recessed into the ceiling, we need to install and wire the fixture now. That's the case with this ceiling fan here in the bathroom, as well as with the light over the tub.
Once all the cables have been run through the boxes, we can start making some of the connections. And we'll begin by cutting the cables to length and stripping off the plastic sheathing. And the next thing I'll do is connect the bare copper ground wires together. The end of this bunch gets a wire nut. I can also connect the hot leads to each other, so that power is fed out to the outlets in this room and to the light. Then everything gets carefully folded back into the box to get it out of the way for when we attach the drywall. When I'm done with the connections in each box, the only loose wires should be the wires that are going to go to the fixture. In this case, it's the 2 wires for the switch.
We'll leave all these rungs of Romex hanging loose here at the sub panel. In a do-it-yourself remodeling situation, we recommend holding off on making the final connections until all the switches